All right, in our next lesson, we're going to continue working with radical expressions. And today we're going to see what does it look like when we multiply or divide radical expressions. And in the first lesson, right, we spent a lot of time learning how to simplify radical expressions. So we'll continue to have to do that. Once we multiply or divide, then we need to simplify. So let's look at our objectives here. The first is just multiply radical expressions. The second is divide radical expressions. All right, so let's look at what are the rules for multiplying radical expressions. Okay, now what this says is if we have two radical expressions, so we have a times the nth root of c and b times the nth root of d. In other words, we have radical expressions that have both a radicand inside and a coefficient in front. If those are real numbers, then when we multiply them together, basically we multiply the coefficients in front, a and b, and we multiply the radicands inside, c and d. Now, the one other requirement is that in order for us to multiply radical expressions, they have to have the same index. In other words, we could not multiply a square root of 2 times the cube root of 8, okay, because they don't have the same index. All right, let's look at some examples of see how this would work. So we have 2 times square root of 3 times 3 times square root of 8. Okay, so we look again at the rules here. We're going to multiply the coefficients, the 2 and 3 together, and then we're going to multiply the radicands, the 2 and the 8 together. So we do that, go ahead and simplify, right? So we'd have 6 times the square root of 16. Okay, so we basically multiplied at this point, but always ask yourself, can I simplify what's inside the radical? And if we see the square root of 16, we say, oh, that's a perfect square. That is equal to 4 squared. So I can bring out the 4, and we'd have 6 times 4 is 24. And again, because we're taking the even root of a positive number, we get both a positive and negative result here. All right, let's look at another example. Cube root of negative 5 times cube root of 25. Now, there's no coefficients here, right, in front, so we don't have to worry about that. We just have to multiply the radicands together. So negative 5 times a positive 25 gives us a negative 125. Is that a perfect cube? Well, refer to that sheet I gave you, right, of common squares, cubes, fourths, and fifths, and you would see that, yes, 125 is a perfect cube. Negative 5 to the third power would give us a negative 125. So our final answer here is negative 5. All right, how about this one? Cube root of 5 times the fourth root of 15. Now remember, our rules are that they have to have the same index. Notice in this problem, they do not have the same index. We have cube root and fourth root. So all we can say here is that we can't multiply or simplify any further than what is already given to us. All right, let's look at one last example here. So square root of negative 3 times square root of 12. Okay, so they're both square root. We can multiply these together. But notice whether we take the square root of negative 3 or take the square root of negative 36, right? If we multiplied those together, in either case, we would be taking the even root of a negative number, and that will not give us a real number. That only gives us an imaginary result. So we cannot multiply those. All right. So let's see how all this works with not just integers, but variables. So here's our example. 2 square root of x times y times the square root of 4x squared y. All right, now we want to multiply the coefficients and the radicands together. So we have 2 as one coefficient and 1 for the second one. So that just gives us 2. We have just the 4 inside as a radicand. But notice we have an x and an x squared. So if we multiply x times x squared, that gives us x cubed. Remember the rules, if we're multiplying two powers, we're going to add the exponents. And then y times y gives us y squared. All right, we've multiplied, but now we'll go back to simplify, right? So we want to rewrite this as perfect square factors. So the 4 we can rewrite as 2 squared. The x cubed we can write as an x squared times x. And then y squared is already a perfect square, so we leave it that way. So what can we bring out? We can bring out a 2, an x, and a y. So let's bring those out and go ahead and multiply everything that's in front here. So 2 times 2 gives us 4xy, and we still have a x left inside the radical. All right, let's try another one here. Cube root of 25xy to the 6th times the cube root of 5x to the 4th y squared. Okay, so same thing. We're going to multiply the coefficients, the 5 and the 25. That gives us 125. X times x to the 4th gives us x to the 5th. And y to the 6th times y squared gives us y to the 8th. Notice we're adding the exponent. 6 plus 2 gives us 8. All right, now let's simplify. So 125, that is a perfect cube. Right? We can rewrite that as 5 squared. X to the 5th, we can break into 2 factors, x cubed, our perfect cube, and then we still have an x squared left over. Y to the 8th, we can factor that into y cubed times another y cubed, and then we still have a y squared left over, right? So the 3 plus 3 plus 2 gives us a total of 8. All right, what can we bring out in front? Well, anyone that has a cube, we can bring out. So the 5, one of the x's, and 2 of the y's can all be brought out front. What's left inside? An x squared and a y squared. All right, so let's just multiply those together, right? 5x, and then the 2 y's gives us y squared. And we're left with the cube root of x squared, y squared. All right, here's a couple for you to try. Just do these on your own paper. All right, we multiply this, we get a -8, and -8 is a perfect cube of -2 cubed, so our answer is -2. Let's try this one. So we're going to get 16x squared. Both of those are perfect squares, so square root of 16 is 4, and square root of x squared is x. Let's try this one. Cube root of 3x to the 4th times cube root of 9x squared. So we multiply them together, we get 27x to the 6th. We're taking the cube root, and 27 is a perfect cube, so we have 3 cubed. And then x to the 6th, we can factor into 2 perfect cubes, x cubed times x cubed. So we bring out a 3, an x, and another x, and we get 3x squared. All right, last one. Cube root of 3 times the square root of 27. Now, hopefully you caught yourself and realized that the indexes are not the same. We have a cube root and a squared root. So in this case, all we can say is that we can't multiply since the roots are not the same. All right, let's talk about dividing. So dividing works in a similar way. So if we have 2 radicals and they have the same index, the way we're going to divide is that we can rewrite 2 separate radicals as a single radical. Right? So to take the a, the radicand of the top in the numerator, and divide it by b, the radicand down in the denominator, we can rewrite it as a single radical. And then hopefully once we write it as a single radical, we can simplify. So let's look at an example here, right? We have cube root of 32 divided by cube root of -4. So a good first check is to ask yourself, can I simplify it the way it's written? In other words, is 32 a perfect cube? Is -4 a perfect cube? Now, in this case, the answer is no, right? Neither of those are perfect cubes. So if that's the case, then we want to move to the next step and rewrite this as a single radical. But if you can simplify it right at the beginning, that's always a good first step. All right, so let's put both of these radicands inside a single radical. So now we have 32 divided by -4, which is a -8. And now, can we simplify that? The answer is yes, right? Cube root of -8 is -2. All right, let's try another one here. So cube root of 24 x to the fourth, cube root of 3x. Now you could say, well, x to the fourth, we could factor out an x cubed there and do a little simplifying, but unless the entire radicand can be simplified, let's go ahead and rewrite it as a single radicand and do the division. So 24 divided by 3 gives us 8. X to the fourth divided by x gives us x cubed, right? So remember, when we multiply powers, we add the exponents. When we divide powers, we're going to subtract the exponents. So 4 minus 1 gives us x to the third. And then can we simplify that? Yes, 8 is a perfect cube, and x cubed is already written as a perfect cube. So our answer there would be 2x. All right, let's try a couple more, see if you can do these. Square root of 243 divided by square root of 27. Right, so neither of these are perfect squares, so we're going to go ahead and rewrite as a single radical. And if we do the division on our calculator, we see that 243 divided by 27 is 9. 9 is a perfect square, so that gives us 3, in this case, plus or minus 3. All right, let's try this one, see if you can do this. All right, we're going to rewrite, since neither of these are perfect cubes that we can completely simplify. So we're going to rewrite it as a single radical and do the division, right? 128 divided by 2 is 64, and x to the 8th divided by an x gives us x to the 7th. All right, can we simplify this now? 64, is that a perfect cube? Well, it's not a actually, it is a perfect cube, right? 4 times 4 times 4 gives us 64. And then the x to the 7th, we can factor that into an x cubed, another x cubed, and x. So we can bring out a 4 and 2 x's, and we're left with a cube root of x inside the radical. All right, last one, I think here. Square root of 12, x to the fourth divided by square root of 3x. Go ahead and see if you can simplify this. All right, we're going to write them as a single radical. Let's do the division. So 12 divided by 3 gives us 4, and x to the fourth divided by x gives us x cubed. Now let's simplify. Well, 4 is a perfect square, right? And x cubed we can write as an x squared times x. So we could bring out the 2, bring out one of the x's, and we still have a x left inside the radicand. All right, that's it for the lesson today. There's an assignment that goes with it that'll give you some extra practice.